Controlled quantum dynamics is where we're finally getting hold of individual quantum systems and using them to develop groundbreaking technologies.
Quantum mechanics is over 80 years old, and yet we still don't really understand what's going on in this theory. A lot of what we do here at Imperial is to get into the guts of the theory, which is quite challenging mathematics, but it's really interesting. What we've discovered in the last 10 or 15 years is that even though we don't really understand what's going on, there are still things we might be able to do with quantum systems. Quantum technologies such as quantum computing, quantum cryptography, quantum information can be built if we can just control small numbers of quantum systems such as atoms and ions.
Okay, so if you want to trap an ion, how do you go about doing it? What you do is you make some sort of electrode structure which you're going to put inside your vacuum chamber, and you're going to put voltages onto those electrodes such that if the ion is somewhere inside your vacuum chamber, you always push it back to the center of the chamber. Effectively, that's what you're trying to do. So having done that, now you've got a single ion and it's sat in the middle of your vacuum chamber. And that for me really is the amazing thing, the ability to take an individual atomic particle, hold it in a well-defined place in your laboratory and do experiments on it without it interacting with anything else. So we do it with trapped ions, but of course there's lots of other things that you can use. There are other people in the building trapping neutral atoms, which is in some ways more difficult, but there are ways of doing it, and you do it by pushing these atoms around with lasers or by pushing them around using magnetic fields. And the magnetic fields are generally made by structuring a surface material, magnetic material, into interesting shapes, and then dropping atoms onto the material. And this thing you could call an atom chip. Sort of mimics the kind of thing you'd have with ordinary electronic chips. But now the things that are moving around on the chip are on the surface, and they're individual quantum systems. They're these individual atoms.
So the DTC is a 4-year fully funded PhD. The first year you do a master's, 6 months of teaching and training, followed by 6 months of a project which acts as a taste test for the research you might end up doing in your PhD. The CQD program involves courses on subjects such as quantum information, quantum optics, experimental implementations of CQD, mathematical methods, instrumentation, which gives you a hands-on component, and the chemistry of cold matter. So you really get a well-rounded balance of theoretical and experimental aspects of the field.
One of the big differences about doing a PhD through the DTC route as opposed to the ordinary route is that instead of just getting the usual amount of funding that you get, you would normally get your funding for your stipend and paying your fees. The DTC comes with extra funding effectively, so extra funding comes in to the college through the DTC route, which we're allowed to spend, in fact we have to spend on your well-being one way or another. And so we're able to do extra things. For instance, on day one you arrive, you get a laptop given to you, which is your laptop. You get to keep it for the time that you're here. There's a suite of rooms that has been handed over to us explicitly for the use of the DTCs, the Whiteley suite. And in that suite of rooms you get an office, you get a desk that you can sit at and work. There are meeting rooms and rooms where the lectures take place. There's a kitchen. There are areas where you can stand at a whiteboard and chat with other people. And all of these things I think are really extra ingredients that make the DTC something special.
The DTC really is a PhD with a difference. The students get their own laptop given to them when they arrive, their social events are funded, they get to go away on trips and do things. It's really a different PhD experience.
Imperial College is a great place to do research. It's extremely well funded, there's great equipment around the place that you can get your hands on and actually play with, and let's face it, that's one of the fun things about being able to do research, getting your hands on equipment and actually being able to play with it.
We're teaching students to master all aspects of modern quantum mechanics as well as the radical new technologies it implies. And if that sounds appealing, then this DTC is the place for you.